Okay, I hear the recording in progress. All right, so we're finishing up 10.5 on the conic sections. We've done the parabola, some of the ellipse. I'll do more of the ellipse and the hyperbola. Okay, so schedule-wise, we are here. So try to finish everything today. If I don't, I still have a little bit of tomorrow. Tomorrow, I'll let you have for questions and answers if there are any. The next test is this coming Friday. Okay, so if you haven't already done so, start putting together your formula sheet, your cheat sheet for the test. You should know all the rules by now. You're allowed that one formula sheet, front and back, and a calculator, but nothing else. Okay, and have your polar graph paper ready for the exam, right? So I will more than likely have you do a polar graph. I will not give you a 4 theta one like on the quiz. That's just too long. So don't worry about that. Maybe bring a couple just in case you mess one up, like I might mess up. So bring 2 just in case. Okay, so have your polar graph paper ready. All right, so it's just chapter 10, 10.1 and 10.5. You also submit this homework by half an hour after the test. I will start accepting the homework immediately after class tomorrow. That would be fine. Okay, 70% homework requirement. You know that by now. If you don't turn in the homework, I don't grade your exam. Same as always. All right. Okay, so let me go back and do as much of 10.5 as possible. Maybe I'll finish today, but if not, I still have a little bit tomorrow. Tomorrow, you may ask me any questions from any section and then be ready for the test on Friday. Okay, so again, start putting together your formula sheet, your cheat sheet, if you haven't already done so. Okay, so we're going back to the ellipses now. We did some yesterday, and we'll do some more today. In problem 37, they're telling you the foci are plus or minus 2, 0, and the vertices are plus or minus 5, 0. Okay, so F for focus, 1 focus, 2 foci, 1 vertex, 2 vertices. The vertices are the endpoints of the major axis. Major axis is the larger one. All right, so the vertices are here and here. The center's at the origin, which is nice. So that gives me the A. A is 5, C is 2. C is the focal distance, distance from the focus to the center. A is the distance from the center to the vertex. So C is 2, A is 5. A squared equals B squared plus C squared for the ellipse. Okay, so make sure this is the formula you use for the ellipse. So A squared is 25, C squared is 4. That makes B squared 21, or B is radical 21. Right, so they want the equation. It's just x squared over A squared, x squared over 25, plus B squared, y squared over B squared, y squared over 21 equals 1. Okay, so up and down is going to be square root of 21. We don't care what it is exactly. It's 4 point something. Okay, but they just want the equation, and there's the equation. It's 39. They tell us the foci, 1 focus, 2 foci, 0, 2, and 0, 6. Vertices, 1 vertex, 2 vertices, 0, 0, and 0, 8. Okay, so that tells me it's bulging. The graph is bulging horizontally. So the larger number should be underneath the y. So first I go halfway between either the foci or the vertices and have 0, 4. Halfway between 0, 2 and 0, 6 is 0, 4. Or halfway between 0, 0 and 0, 8 is 0, 4. So the center is 0, 4. I know how to translate that. Okay. So translation, meaning move, will be x minus 0 squared and y minus 4 squared. So that's an automatic. Okay, then the distance from the center to either vertex, that's my A, it's 4, meaning how far is this point from either here or here, the 2 vertices, that's 4, so A is 4. Focal distance, C, is 2. Distance from the center to either focus is 2 units. And I do A squared equals B squared plus C squared. Put this formula on your formula sheet. For the ellipse, there's a different formula for the hyperbola. So A squared is 16 equals B squared plus C squared is 4. 12 equals b squared. So b is radical 12 or 2 radical 3. But we have everything we need. So x squared over b squared, the smaller number should go in the x direction. So it's 12 plus y minus 4 squared over a squared, 16 equals 1. Okay, so that's what we have for that one. Okay. Okay, so that was pretty much it for the ellipse. So I'm ready to start the hyperbola now. Back to where we were. Give me a moment here to find my place. Okay, so the hyperbola, of which there's two types. Page 677. Hyperbola opens to the left and right. Page 678. Or it can go up and down. You're welcome to put those on your formula sheet. Excuse me. So figure 12, x squared over a squared minus y squared over b squared equals 1. The x is positive, the y is negative. It's going to go left and right. These are asymptotes. The graph gets really, really close to the asymptotes, but doesn't quite touch it. The other type is y squared comes first. Y squared over a squared minus x squared over b squared equals 1. The hyperbola is going to go up and down. And again, you have asymptotes. Okay. I would say don't even bother putting down this roof for the asymptotes. You can just figure them out as you go along, and I'll show you what I mean by that. Okay, so this type is x squared over a squared minus y squared over b squared equals 1. Okay, it's going in the x direction, kind of. If y squared comes first, y squared over a squared minus x squared over b squared equals 1, the hyperbola goes up and down. It's going to be asymptotes. I'll be asking you to draw the asymptotes. And please notice, this is the Pythagorean relation that you're used to. C squared equals a squared plus b squared. I prefer to say a squared plus b squared equals c squared because that's what we're used to. Okay, so for the hyperbola, a squared plus b squared equals c squared. That kind of looks like the Pythagorean theorem. For the ellipse, a squared is the largest. A squared equals b squared plus c squared. Okay. By the way, the designation for A and B this time is not which one is larger. Okay. A can be bigger than B, A can be smaller than B, or they can even be equal. Okay. The designation for A and B is which one gets the positive and which one gets the negative. Okay, so here's how a hyperbola looks like in general. Now, I'm going to have you draw a box for me. The text doesn't give us a box, but you'll be drawing a box for me, and I'll show you how to draw the boxes. So how do I analyze hyperbolas? Okay, so for the hyperbola, a squared plus b squared equals c squared. For the ellipse, a squared equals b squared plus c squared. Yeah, side note, if we were meeting face to face, or the last time I taught the class, the students had to memorize this. And I had a memory trick for that also, but you don't have to worry about it now. Okay, 19. Y squared over 25 minus x squared over 9 equals 1. Graph it. Y is first, so I know it's going to go up and down. Okay, A is the square root of this, 5. B is the square root of this, 3. A squared plus b squared equals c squared. So 5 squared plus 3 squared equals c squared. C squared is 34. C is radical 34, which is about 5.8. Okay, so here's the way it works. from my center, I go 5 up and down in the y direction. So 5 up, 5 down. B is 3 left and right. Okay, so if this were an ellipse problem, if it had a plus, all you would do is just go like this and that would be it. Okay, but instead, you take these 4 points, 1, 2, 3, 4, draw yourself a box. So you draw a box, draw the diagonals, connect the diagonals, they'll always go through the center. Those are going to be my asymptotes. Okay, if this were the horizontal type of hyperbola, I would connect like so and curve toward the asymptotes. Since I know it's vertical because y is first, I go like so and like so. So the thing in red is the actual hyperbola. The box is not the hyperbola. The asymptotes are not the hyperbola in green. The actual hyperbola is in red, but you need the green stuff in order to get the hyperbola. And for the foci, well, it's almost 6. So I go a little bit up here. So here's one focus. If you can read, that's F1, 0, radical 34. F2 is 0, negative radical 34, roughly here. And label the vertices. Vertex 1, 0, 5. Vertex 2, 0, negative 5. And yes, the text gives you a formula. You can either do A over B or B over A to find a slope. I would say don't even worry about that. Just look at the picture from what you already know. Okay, what's the slope? So 1, 2, 3, 1, 2, 3, 4, 5. Rise over the run is 5/3. So y equals 5/3 x. This will automatically be negative 5/3 x. So the equation of the asymptotes are y equals 5/3 x and y equals negative 5/3 x for the hyperbola. There we go. Okay, x squared minus y squared equals 100. Problem 21. X squared minus y squared equals 100. Okay, the right hand side is supposed to be 1, not 100. So I just divide by 100. X squared of 100 minus y squared of 100 equals 1. Okay, this time x is positive, y is negative. So it's going to go like so, left and right. Okay, so again, put this on your cheat sheet, page 678. This is if x squared comes first and it's positive. This is if y squared comes first and that's positive, and therefore x is negative. All right, so take the square root of this. A is 10, b is 10. A squared plus b squared equals c squared. 100 plus 100 is c squared. C squared is 200. C is radical 200, which is 100 times 2. 10 radical 2, which is about 14. All right, so my box is going to be a square, center of the origin. I go 10 left and right, 10 up and down. Draw myself a box. Draw the diagonals, which are clearly y equals x and y equals negative x. Okay. Now, if the y were positive, it came first, and x is negative, just like the previous problem, I would take these 2 points and just curve it toward the asymptotes. However, since we already know it's the left and right variety of hyperbola, I just go like that and like that. Okay, try to get this thing in focus here. Right, so my vertices, vertex 1 is negative 10, 0, and vertex 2 is 10, 0. Then I go out to roughly 14 it was. So my 2 foci are here and here, negative 10 radical 2, 0, and 10 radical 2, 0. So there's my hyperbola. Okay, the next one I'm writing, well, it's called 23 star, which is much harder than the 23 in our book. So if I show you how to do this one, you should be able to do anything else that's there. 4x squared minus y squared minus 24x minus 4y plus 28 equals 0. Okay, so this is one of those completing the square problems. Move over to 28. Put the x squared with the x together. Put the y squared and the y together. Okay, factor out the 4. 4 parentheses x squared minus 6x. Factor out the negative 1, y squared plus 4y. Now I complete the square. Half the coefficient of x squared. Half of negative 6, negative 3. Negative 3 squared is 9. So plus 9, but by putting plus 9, I'm really adding 36 because it's 4 times 9. Same thing over here. Half of 4 is 2. 2 squared is 4. Plus 4, but that negative sign really means it's minus 4. So I subtract 4 on both sides. Okay, this comes out to be 4. So factor 4 times x minus 3 squared minus parentheses y plus 2 squared equals 4. Divide both sides by 4. X minus 3 squared over 1 minus y plus 2 squared over 4 equals 1. Okay, so we finally got it the way that I wanted to. The center is going to be 3, negative 2. The center got translated 3 to the right and 2 down. So the center is 3, negative 2, like so. Okay. I know it's going to be the left and right variety because x is first, y is second. So it's going to open like so. All right, so take the square root of each of these guys. A is 1, B is 2, square root of 1 is 1, square root of 4 is 2. A squared plus B squared equals C squared. 1 plus 4 equals C squared. C squared is 5. Therefore, C is the square root of 5, which is about 2.2. So here we go. Center is at 3, negative 2. I go 1 unit left and right, 2 units up and down. Draw my box. Draw the 2 diagonals. They become the asymptotes. This is horizontal, so the horizontal types. Take these 2 points and curve it toward the asymptotes. If y was first and x was negative, I would take these 2 points and curve it toward the asymptotes. Okay, so all that's left is labeling these points. Let's see, this was 3, negative 2. So this vertex is 2, negative 2, V1. And vertex 2 is 4, negative 2. How about the foci, focus? Well, I start from the center, I go radical 5, left and right, it's about 2.2. So the center was 3, negative 2. I just go 3 minus radical 5, negative 2, and 3 plus radical 5, negative 2. So it goes like so. Last thing is the equation of the asymptotes. Well, I know the center in both cases is 3, negative 2, so I'll use the point slope form. This slope is over 1 up 2. The other one is over 1 and down 2. So the slopes are 2 and negative 2. So this equation is y plus 2 equals 2 times x minus 3. Just leave it like that. And this one's the same thing except the slope is negative 2. Y plus 2 equals negative 2, x minus 3. So that's the equation of the asymptotes. Okay. Right, so that is that. Quick review. If you want to put on your formula sheet again. So parabola, there's 4 types, opening up, down, right, and left. X squared equals 4py, x squared equals negative 4py, y squared equals 4px, y squared equals negative 4px. Okay. Focus is always on the inside, directrix is on the outside. Ellipse, bulging either horizontally or vertically. The vertices are the endpoints of the major axis. Okay. x squared over a squared plus y squared over b squared equals 1, where a is the larger, goes like this. A is the larger underneath the y, it goes like so. Hyperbola, x squared over a squared minus y squared over b squared equals 1, left and right. Y squared over a squared minus x squared over b squared equals 1, up and down. And a squared plus b squared equals c squared. Okay, and let's see, I was going to do some more. Here I do see a question in the chat. Okay, can you review exactly what the focus is? Okay, I never actually went over that in the interest of time, okay, but there are physical properties for the focus. Yeah, so I'm not sure if I'll get to it. So I'll have to hold off on that. So if I never get to it, there's the normal physics, mostly physics idea of focus. So if I have leftover time, I'll talk about it. But if not, I need to at least get you what you need to know for everything here. Okay, about the, but it has to do, yes, as the English word focus also, but mostly in a physics standpoint. Okay, let's see. 43, give the equation of the hyperbola where the vertex is plus or minus 3, 0. Focus is plus or minus 5, 0. It's 43 here. Vertices are plus or minus 3, 0. Foci plus or minus 5, 0. All right, so A is 3, C is 5 for the hyperbola. B is 4, it's a 3, 4, 5. A squared plus B squared equals C squared. 9 plus B squared equals 25. B squared is 16, B is 4. It's going left and right, that means I know X is first. So X squared over 9 minus Y squared over 16 equals 1 is the equation of my hyperbola. Okay, 41. Vertex is -3, -4, and -3, 6. Focus -3, -7, -3, 9. Okay, so I go halfway between either this pair or this pair to get the center. So halfway between these would be -3, 1. How do you do that? Just average the x's. Well, the average of -3 and -3 is still -3. But to average, you add them up and divide by 2, right? So 6 and a -4, add them up, you get 2. 2 divided by 2 is 1. Or I could do that here also. 9 plus -7 is 2. 2 divided by 2 is 1. So the vertices are -3, -4, and -3, 6. So C is -3, 1. So A is 5. So it's 5 units either vertex. C is 8. So from -3, 1 up to -3, 9 is 8 units. Or -3, 1 down to -3, -7 is also 8 units. Okay, A squared plus B squared equals C squared. A is 5, so this is 25. C is 8, so this is 64. B squared equals 39. E is radical 39. Okay, so I have everything I need. Okay, let's see, this hyperbola, since the vertices are here, it's going to go up and down, which means y comes first. The center is -3, 1. So y minus 1 squared minus x plus 3 squared. Okay, the bottom here is a squared, 25. The bottom here is b squared, 39. So there we go. Y minus 1 squared over 25 minus x plus 3 squared over 39 is equal to 1. Okay, then finally 47. Vertices are plus or minus 3, 0. Asymptotes y is plus or minus 2x. 47, hyperbola. Vertices plus or minus 3, 0. Asymptotes y equals plus or minus 2x. So 1, 2, 3, 1, 2, 3. That gives me A is 3. Asymptote is y is plus or minus 2x. So if A is 3, rise of the run is 2. So if A is 3, 1, 2, 3, I have to rise 6. 1, 2, 3, 4, 5, 6 in order to have a ratio of 2. So B is 6. Delta y over delta x is 2. So if delta x is 3, delta y has to be 6. Which means B squared is 36. So there I go. X squared over 9 minus y squared over 36 is equal to 1. And that's the equation of the hyperbola. Okay, so that's it for the hyperbola. And these are things you want to put on your formula sheet. Okay, so I think I'm pretty much done. Now I'll spend a little bit of time about the idea of focus and so forth. I had mentioned before, for the ellipse, you're given 2 foci and a distance. So I said the other day, let's say the distance is 10, then this plus this is 10, and this plus this is 10, and this plus this is 10, and so on. The sum of the distances is constant. For hyperbola, the difference between the distances is a fixed number in absolute value by definition. So for the hyperbola, page 677, a hyperbola is a set of all points in a plane, the difference of whose distances from 2 fixed points F1 and F2 is a constant. So in the definition for an ellipse, there was a sum was constant. For a hyperbola, the difference is constant. And say hyperbolas occur frequent as graphs of equations in chemistry, physics, biology, economics, and so on. Okay. And that. I can talk quickly about the word focus for parabolas. Okay, as you might guess, the English word focus. So either 2 ways, if you have a parabolic shape or in 3 dimensions, a parabolic dish, like those dishes for antennas or cable TV or whatnot. Okay. If you emanate a pulse from the focus, it hits the parabolic dish, all the rays will come out parallel. Okay. And it goes the other way too. So if you have a bunch of parallel rays that come and hit the parabola, they're all going to hit the focus. Okay. So it's my understanding that your headlights in your car, the shape is parabolic because if you aim the parabola like so, 3-dimensional paraboloid, and send out a beam of light and it hits the parabolic dish, then all the rays of light will come out straight out. And that's the way you want it, right? When you're driving, you want to be able to see in front of you. You don't really care that much about here or here. You want to be able to see this direction. So it's set up in your headlights to be parabolic in shape. And so for the word focus. For the ellipse, there's also a reflective property. If you have something that looks like this, okay, if you're standing at one focus and you bounce off sound or light or whatever, it'll always hit the other focus. Okay, and likewise, if you're here and you bounce off a ray of light or a sound wave, whatnot, it'll go through the other focus also. So that was extra. I was only going to say it because I was finished with everything I needed to say over here. Okay. All right, so I think I've actually finished everything I needed to say. And if I miss anything, you can bring it up, because otherwise, next time I'll start sequences in series, which is what's coming up next, the last chapter, which I won't start today, and I wasn't planning to start tomorrow either. But again, we quote unquote only have one more chapter on infinite sequences in series, but it's the biggest chapter, right? So that's what we have there. Okay, so I think I was successfully able to finish everything I needed to do. I'm going to go ahead and mark this off. So coverage for the test on Friday is everything here. So tomorrow you may have the entire time for questions and answers. And Friday's a test. Then We just have the one last chapter, but it's a long chapter, as you can see. We have here, so we have the rest of the course to finish everything we need to. By the way, this exam 5 on Thursday, I think I'm going to go ahead and make it Friday anyway. I'm not positive on that. Okay, but this was if we were meeting face to face, right? If we met face to face, I'd have to scramble to hurry up and give you back the test the next day. But since we're not meeting face to face, it doesn't really matter anyway. So I can go ahead and give you the test on Friday. Our final exam is on the 17th. So I would email you the solution. So even if you don't get your individual test back until Monday or Tuesday, it doesn't matter. You can start reviewing for the final, even if we have it here. So in short, I may decide to have the last exam still on the 10th. And then you have the full week, it looks like. So our final exam is on the 17th. And so I will email you the solutions on that Saturday, as I normally do. Okay. All right, but otherwise, I think I'm done for today. So let me stop the share and see if anybody has any questions for today. Otherwise, we're done. So check the chat. Okay, any questions, please? All right, so tomorrow, come up with questions in any section, and then the test is on Friday. All right, okay, have a good day. See everybody next time. Thank you.
Thank you.